Okay, good morning, ladies and gentlemen. My name is Agus Suryanto, and I'm from Department of Mathematics, Brawijaya University. And I'm very happy to be here this morning and have opportunity to introduce Professor Edi Tribaskoro. He is a professor at Combinatorial Mathematics Institute Teknologi Bandung. Professor Edi Tribaskoro received his PhD degree from the University of Newcastle, Australia in 1996. His main research interests are graph theory and combinatorics, and he is a pioneer in the field of in this field in Indonesia. He has published over 100 research papers and produced 17 PhD graduates. For his contribution to this field, he has been awarded the Habibie Award in Basic Science Research in 2009. And the Australian Alumni Award for Excellence in Education also in 2009. And the Extraordinary Intellectual Quality Award in 2010. And he is currently the president of the Southeast Asian Mathematical Society and a member of Scientific Committee of CIMPA. And now we are happy because he has a chance to be here with us to give a talk entitled Ramsey number for graphs. And without any delay, please welcome Professor Edi Tribaskoro.
Thank you very much, Agus, for the introduction. Okay, good morning, ladies and gentlemen. Actually, probably I should come forward to see my slides. First of all, I would like to thank the organizer for inviting me here. This is a great pleasure to be here again. I think last year I've been here several times for not occasions, and this year is first time. Yeah, so. It's good to be here, to be in Malang. Okay, this is my title, Ramsey numbers of graph, one of my favorite research topics. And this research topic actually is hot topics in graph theory. Okay. I would like to give you some introduction because you are from various fields here. And then also I like to mention about 4 problems with sharing the same theme with Ramsey numbers. And then I explain about the development of classical Ramsey numbers. And then the last one, I'm going to speak on the graph Ramsey numbers, which is my current contribution. Actually not current, because I already gave some contribution since I have my first PhD student, 2001. Okay. I start with a very simple example here that you already knows. If you have 3 persons in a room, then you immediately you can say that there are always 2 persons in the same gender, right? Because we have 2 genders, so of course it's very simple example. But now, if you have 9 people, if you want to make sure, not 9, 6, rather. If you want to make sure that there are always 3 persons to know each other, or 3 persons to not know each other, then you must invite 6 persons. If you invite 6 persons, no matter who they are, then there will be this kind of relation. Either 3 persons knowing each other, or 3 persons to not knowing each other. And 6 is the least number. If you have 5 people, then you can avoid this kind of relations. Okay. And yeah, I will show you later. Then, okay, if we have 5 points in the plane, no matter how you draw it, the 5 points on the plane, but there are no 3 points make a collinear, then you will always can have 4 points forming a convex foreground. Always, if you have 5. But 4, of course, you can avoid that one. So if you have 4 like this, then, okay, you cannot have a 4 convex ground. Okay, and then again, 5 is the smallest one. And now, if you have a 9%, then there are at least 3% know each other, or 4% do not know each other. So, yeah. So this is a simple example. Okay, the last one here. If I'm dealing with the first 101 integers, so if you start from 1 to 3 up to 101, then no matter how you order it, then there are always 11 of them forming increasing sequence or decreasing sequence, no matter how you order it, 110. But if you have only 100, the first 100 integers, from 1 up to 100, then you can order like this, yeah? If you order like this, then okay, I do not have 11 elements in this number makes increasing sequence or decreasing sequence. Because why? Okay, if you make a sequence, then you have to take, okay, if you take 2 numbers from here, then you're going to make increasing sequence. But if you take 2 here, then you cannot take this one, because you already increase, yeah, the number. So only 2. But if you take only 1 here and then 1 here, you will make a decreasing sequence. But now you have only 10 poles here. So at most, you only have 10 elements in decreasing or increasing sequence in that ordering. But if you add 1 more, which is 110, 101, then no matter how you order this number, then you always have 11 elements making increasing or decreasing sequence. Okay, that's actually in the nature of Ramsey theory. So Ramsey theory was initially studied in logic, actually. So we like to find the procedures to determine the consistency of any logical formula. So this studied by Frank Plantan Ramsey, who's a student of Russell, famous mathematician, and then Moore, and then Wiggins, and also Keynes, famous economics, I think. Yeah, he's good in economics. So, this appears in logic, but now they are transformed in several areas, not only in graph theory, but also in set, also in ergodic theory, and so on. Okay, the theme is, they say that complete disorder is impossible. So, this is the theme of Ramsey theory. So they say that, okay, if you want to find prescribed size structures, yeah, our structure with prescribed size, then, okay, if I look at, yeah, in the higher position, then, or higher context, then if I have a sufficient enough number points or the objects, then we can see that we will have this subsystem or substructures. So in non-technical interpretation of Ramsey theory is that one. Every sufficiently large structure, regardless how disordered it might be, then this large structure will contain an orderly substructure of any prescribed size. So this is the nature, or this is the theme of Ramsey theory. Okay. Okay, it comes in two versions, one in infinite and one infinite. And probably this talk I will only mention on finite version, because we will restrict it to dealing with finite case here. Okay, given R, N, and K here, R and K here are integers, then the theory says that they're always integers. Yeah, they're always integers. M0 here, yeah, such that if you have M is greater or equal M0, so if you have the size of M is greater than M0, M0 is the Ramsey, next we call it Ramsey numbers, then if you have a collection of R or subset with R element from this set with M element, then if you color by K colors, then you always have monochromatic here as N, which has a subset of R element from this one, from Sn with the same color. So they're monochromatic color. Remember in our previous example, I always say that, okay, there will be 3 persons knowing each other, that means monochromatic, yeah, that means the same color, they have the same color. Yeah, you can say there's some relation, knowing each other, or do not knowing each other. Do not knowing each other is the other colors. Okay. Yeah, if you take R is equal to, then actually this Ramsey theory applied to the graph theory, and the first one done by Erdős and Szekeres in 1935. Okay. Now, I like to mention 4 problems which sharing the same themes here with Ramsey. Okay, and they all problems tends to be very, very difficult to be solved here. Okay, the first problem is in the following, dealing also with numbers. So if you have numbers, so we like to find integer k. Given integer k, and we like to find integer s as a function of k here, such that if you have integers from 1 to up to s, if you color by k colors, then there are always x, y, and z at the same color, in the same class or the same color, then satisfying this one, x plus y equals z. Okay, so we will like to find the smallest number s here, satisfying this one. Okay, so show that this number is bounded by this number, is big one, the upper bound of this number, which is n factorial time e. Yeah, so it's very big. Then, okay, but this number is already improved, but it's only slightly improved here by this bound, so by this number, so n factorial, and then instead of a, you have a minus 1 here, and divide by 24. And okay, but because this problem is quite difficult, then only four numbers we know so far, which is if k is equal 1, that means if you play only one with one color, then okay, you can have s, the smallest s is actually 2, because if you have 2, you always have this one. You always have this property, because if one is color 1, and then yeah, the other one is we don't have the color. Okay, because the color is only 1. And if k is equal to, then s is 5. Why 5? If I have 4, 1, 2, 3, 4, then you can color like this: 1, yeah, with red, and then 4 with red, and then 2 and 3 with with black here. So I don't have x plus y equals z. Yeah, x plus y equals z with the same color. For example, like, okay, if I have 1, x is equal 1, and then y is equal 1, yeah, I can have the same number, x and y, yeah, x and y, and then if I sum, then we have 2, right? So x is 1, and then y is 1, so x plus 1, and then equals z, z is 2, so that means, okay, they're different color, yeah? Yeah. But if you add one more here, 5, 1, 2, 3, 4 until 5, no matter how you color these numbers from 1 to 5, with 2 colors, you always have this kind of relation. So x plus y equals z in the same color. Okay. Why is that? I can show you here. Okay, suppose if 1 is red, and then of course 2 it must be black. Because if 2 is red, then I have 1 plus 1 equals 2. So in the same color. So 2 it must be black. But now it's 2 is black, then 4 must be red. Because 2 plus 2 is 4, right? So 4 it must be red. If 4 must be red, then 5 here, if you have 5 here, this is already red. So this is must be black, right? 5. Because 1 is red already, and then 4 is red already, and then 5 must be red, yeah. Must be black, cannot be red. But if 5 is black, then look, we have 2 is already black, and then what about 3? If 3 is black, then it's not possible. So we have a 2, 3, and 5 here, yeah, making x plus y equal z. So 5 is cannot be black, but 3 cannot be black, but 3 also cannot be red. Because if 3 is red, then 1 plus 3 equal 4. So 5 is the smallest number. For k is equal 2. Yeah. 14 is the smallest number. Why 14? If I have 13, I can arrange like this with 3 coloring. With 3 coloring, we can avoiding this kind of property. But if 15, then okay, you cannot avoid this one. Okay, I don't show this one. It's, yeah, okay. Usually chemistry like colors, eh? Because when you enter to chemistry program, then you must be tested with colors, yeah. So that's why my slide is colorful. Okay, S4 is 45, yeah, 45. But now, that's the only thing that we know. For k is 5, then yeah, we have the bond, but the exact value we do not know. Look, the bond is still higher here, and then for 6 and 7, which also we only have the bond. Okay, so this is the progress. The second problems, we call it van der Waals numbers. The concept is the same, playing with numbers, and then we color the numbers, and now we like to make sure that we always have monochromatic arithmetic progression on k terms. Yeah. So how many numbers we have to be? We have to have. Yeah. We have to have so that we always have monochromatic arithmetic progression on k terms. If we have our coloring. Look, only 6 values we know so far, which is 3.2, which is 9, and then 4.2, which is 35, 5.2, which is 178, and then this one, and this one. So we have only 6, yes, so far. And now, if we look further, the development of this knowledge about van der Waals numbers, then let's show that, okay, this is the bound. For k is equal 3, but the bond is higher. This is exponential, yeah? A to the R to the C1. So this C1 is constant. If 4, then the bond is much higher. But if in general K comma R, and then the bond is also O. So A to the R, A. So I can read this, this number. So the bond is becoming bigger and bigger. It's giant graph, giant number here. So, okay, so we need, okay, to lower the bond, but so far it's hard to lower this kind of bond. Okay. Next problem, which is we call it Erdős-Szekeres numbers. This is now in geometry. So we like to make sure that there always, this is the prescribed structure that we like to have, which is, what is it? It is a convex k-gon. So here, convex k-gon. So we like to have a convex k-gon. So how many numbers, oh, no, sorry, numbers, how many points, yeah, how many points we should have it here. So if k is 3, so that means we have a triangle, convex triangle, so always 3. If you always, if you have 3 points on the plane, you always have, you can make a triangle, convex triangle. But now is k is 4, then we have 5. I will show you 5. And Erdős and Szekeres show that this number, yeah, the number of points, yeah, required to make a convex k-gon is this number. This is the conjectures. So far we do not know how to prove this one. Yeah, hopefully in the future somebody can prove this. For 4, if k is 4, then 5. And then k5, if k5, then we have the number is 9. And 6, we still do not know whether 17 or higher. We guess, or according to that conjecture, it's 17. But so far, okay, I think nobody can prove this number. Okay, we have the bond here. This is Erdős. This is the godfather of graph theory. And then this is Szekeres, yeah. Okay, and this is the bound, yeah, the bound of this number, yeah, this number. So since 1998, we haven't able to improve this bond. Okay, if k is 4, then this is the proof, yeah. If you have 4 points on the planes, so you have this kind of configuration, either this or this or this one. If you have this one, you have convex gone here, 4 gone here. Yeah, 4 convex. If you have this configuration, then you have this 4 convex gons. Yeah. If this kind of configuration, then you have this is convex gone. So any configuration, you always have a 4 gone, which is convex. But if k is 5, then you need 9. Why 9? If you only have 8, then you can place the points like this configuration. So we cannot have pentagon convex here, because pentagon convex require two points in this kind of set. Yeah, 2 points here or here or here or here. So we cannot have convex one. Okay. Now it comes to classical Ramsey numbers, which is one of the problem sharing the same theme with the previous problems. Yeah. Okay. Somebody call also this problem is party problems. Because why? Yeah. We like to make sure. So the problem is like this. If I like to make sure, yeah, in my party, there are always m people knowing each other, or m people do not knowing each other. Yeah. So how many guests I like to invite in my party, such that, yeah, I always this kind of situation. So I means that if I like to invite guests, so that means arbitrary guests, right? I cannot choose, okay, oh, you guys and you guys and you guys, okay, comes to my party, so that means, okay, I know this one, know this with this and so on. No. So in any, in any situation, yeah, how many guests I should invite to my party, I can make sure that there are always n people knowing each other, or n people do not knowing each other. So if NMS equal 3, so if I just make sure that, okay, 3 people knowing each other, or 3 people do not knowing each other, then, okay, 6 people I can invite. If I have 5, then I can have this kind of situation. If I have this, okay, the black one here, that means knowing each other, but the red relation here, that means do not knowing each other. Yeah. So if you have this one, so you don't have triangle in the black one, or triangle in the red one. Triangle in black one means 3 people knowing each other, but triangle in the red one means 3 people do not knowing each other. So, okay, if you have 6, then okay, I can show that this is enough, yeah, to make sure that way. Okay, this problem started in 2028 in the beginning by Ramsey. Okay, this is, okay, there is some good news. There is the number is finite. The number of Ramsey here is finite. The Ramsey numbers here is finite, and then bonded by this number. So S comma T, and then the number bonded is like this. Okay, good. But this bond is still huge. It's still exponential. So okay, so not so efficient to find the exact numbers here. So we have to deal with them. For example, like here, if you have a 3,4, so that means I like to to make sure that 3 people knowing each other, or 4 people do not knowing each other, then I need 9. I need 9 people to invite to my party here. If 8 people, then not enough, because if 8 people, then I can have this kind of situation. So this one is knowing each other. So this guy know with this guy, and then this guy knowing with this guy and this guy. So look, if I have this kind of relation, then there is no triangle here. Triangle, red triangle. And then the complement here, yeah, the one, if you don't have a line here, you have a line here. So if you draw a complement graph here, then I give a blue lines here, that means do not know each other. Then there is no 4 people do not know each other here. This one, yeah, and this one do not know each. This person do not know this person and this person, but this person, yeah, knowing each other, because in here relation. So, okay, so we don't have K4 here, we don't have K3 here. So that means if you have 8 people, then you can avoid this kind of relation. But now, if you have 9, I can show that, okay, this is the proof. Only short one, yeah. In chemistry, if you prove something, you need long one, right? Because you have to do some experiment and to analysis and so on and so on. Here, okay, sometimes I have a very short proof here. Yeah. Okay, so a few lines I can show that, okay, 3,4 is equal to 9. Okay, but now, what happened on Ramsey, of these classical Ramsey numbers? Only 9 numbers we know so far, yeah, which is, okay, 3,3 is 6, 3,4, 9, and so on. So this number, yeah. And then the remaining are upper bound and lower bound. So we have upper bound and lower bound. Sometimes the gap is bigger, like this, look, 6,11, the lower bound is 253, but the upper bound is 1,800 something. So the gap is still big, yeah. So this is, okay, we know so far. Even, look here, 5,5, yeah. So if you like to make sure that there always, in your guess, always there are always 5 people knowing each other, or 5 people do not know each other, then you need to invite the number of guests is here is 43 up to 49. We do not know which one, which number, yeah, is the minimum one, either in this interval. And there's a joke here raised by Joel Spencer. They say that in 1994, Erdor asked us to imagine, suppose if we have a line force, yeah, from the sky, landing on Earth, and then demanding the values of Ramsey numbers 5,5, or they will destroy us. And then in that case, he said that, Erdor said that, okay, we should marshal all our computer in the world. And also, we should gathering all mathematicians in the world and attempt to find these values. But if they ask us to find Ramsey number for 6,6, then it's better to attempt to destroy the alien, because it's harder to solve this number. So it's better just to against the aliens. So this is the joke, how difficult this problem. Okay, so I'll just show you again the table of these Ramsey numbers. What is the application? Yeah, has many applications here actually, using Ramsey numbers. Even there are some patent from USA, I think, in this area for information technology. Yeah, so they use it in cryptography or coding theory. This Ramsey numbers. So in the field, okay, there are applications in theory, number theory, harmonic analysis, algebra, yeah, and other fields, and also in information technology and so on. In fact, we have a very good papers here, which call it a Ramsey theory application. Okay, and now we are generalized. Yeah, not only having one, or not only having 2 colors, but we can have k colors. Or we not only playing with a complete graph, but we play with multi-complete graph and multi-parted complete graph, and so on and so on. Okay, now I come to the last part of my talk, just emphasizing the development of Ramsey numbers for general graph. Yeah, for classical one, we just focus on complete graph, and now we like to see the development of Ramsey numbers for general graph here. Okay, I start with the bond of these Ramsey numbers, which is proposed by Kavatar, or proved by Kavatar and Harari in 1972. This is the bond if you have any G, any graph G and H, yeah, then the Ramsey number of G, H is at least this number. This number is okay. The chromatic number of H minus 1 times the order of highest component of G minus 1 plus 1 here. So this bond, we call it Kavatar, sometimes we call it Kavatar and Harari bond. This bond is helpful because predict the Ramsey numbers of pair of G, H here. Okay. This is example, small example. If we like to show P3 is path with 3 vertices, and then C3 is cycle with 3 vertices, then the Ramsey numbers for this pair is 5. Okay, this is the proof. I think I just to skip it here, and then okay, I like to talk about the general one here. If you have now general path versus path, then okay, so this is the first one, the first result, I think, yeah. We have in graph Ramsey numbers, this is 1967 here. So by Gerensen and Gyarfas. So if you have two pairs, then okay, the Ramsey numbers is this function. So n plus the half of the number of the pairs in the second one, and then minus 1 here. Cycle and cycle is also interesting. Here there are 3 papers discussing on these Ramsey numbers. Yeah. So the Ramsey numbers is okay in some cases achieving this bond, the bond of Kavadral and Harari, but in other cases is higher than the bond. Okay. Complete versus cycle is also interesting, and still remain some open problems on these values of Ramsey numbers here. So here there is a very good development here. So first of all, okay, they are showing that okay, this is true only for this, yeah, for this requirement, and then okay, now okay, it's also true if m is equal 3 and then n is greater than 3. Also true if m is equal 4 and then 5 and then 6 and so on. So by different authors here, but it's still not completely solved here, because for general cases, these Ramsey numbers, whether equal this number is still not known. So it was conjectured that okay, this is still true for general case. Yeah. Okay, and then some particular graph, tree and complete graph is also interesting here. And this is already solved by Kvatral in 77, which is equal to the Kvatral and Harari bond. Okay, now I like to speak a little bit on my and on our results. Yeah, so since 2001, okay, here we can show that okay, if you have part, yeah, and then will with 5 vertices. This is 4 means on the cycle there are 4 vertices. So we have together will with 5 vertices. Then the Ramsey numbers of this one is 2n minus 1. If we have 6 vertices of will, then we have 3n minus 1. Here. So if even will, we have 2n minus 1. If odd will with path, we have 3n minus 2 here. And then this is the proof. If you have W4 here, then okay, it takes the longest path here. The longest path is less than n, and then takes the second longest path. You also have the length is less than n. Then okay, we still have one more point here, W4 W. Then here is not connected to this 4 vertices. Then this is make a will on the complement, will of 5 vertices. So, and the second pictures showing that the Ramsey numbers of will of 6 vertices is the 3n minus 2. Okay, this we can generalize this method by showing that okay, now in general one. So if even m, we have 2n minus 1. If odd one, we have 3n minus 2. So this is the method of showing these theorems. And then we also, and this this is also improved by other guys from China here. So okay, this is also true with this with this requirement, yeah, in general. But if n is less than m, the situation is different. The situation is different, and then shown by Salman Brusma in 2007. And there are many cases we still do not know about the Ramsey numbers for these particular pairs of path and wheel. Okay, what about star and wheel? Okay, it's also satisfying Kvatral and Harari bound. For some particular cases, yes, but for other cases, not. For example, like here, if you have wheel with even m, then you have 2 numbers here according to n to the parity of n here. But if for even, for odd wheel, then we have the number is the same with Quater and Harari bond. Okay, this is for the odd m. Yeah, odd m is the 3n minus 2 here. And then this result was improved by also these guys, and then okay, later we are improved again in 2005 here. So, but in general, star behave differently compared with path or compared with other classes on the tree here. We like to know about tree and wheel Ramsey numbers, and we can show in 2002 that we have a very nice theorem here for any tree with n vertices compared with versus with wheel with even or odd vertices with small one, which is wheel 4 and wheel 5. Then we have these theorems here. So actually, the Ramsey numbers equal to the lower bound, the Quater and Harari bond. And if I can say, if I can call this theorem, then I like to call Rawan Gubeng station. Why Rawan Gubeng station? Because when we prove this during our travel from Surabaya to Bandung to Surabaya by kereta api Argo Wilis, and then at night we get stuck after discussion, and then in the morning we arrive in the Gubeng station, and then we feel very hungry, and then we like to see to find the food, and then during eating Rawan, then we got the ideas to prove this theorem with my student here, Surahmat, my first PhD student. So sometimes, yeah, a mathematician, I mean, found the methods while they are doing something, while doing activity something. Yeah, some other people went snorkeling or diving on the sea, and then they found some methods to show the theorems. Yeah, it's not like physics or like chemistry. You must work on the lab, right? But mathematics, okay, we can work everywhere. Yeah, we can work everywhere, and then we can. Yeah. So okay, so if I can call that this theorem, because I like this theorem. Yeah, I like this theorem. Then we call it Rawan Gubeng station. Okay, so this is three wheels Ramsey, and then various results we also produce between cycle and wheel. Then, okay, I like to mention about, because the time is limited, so I like to mention our result on union of graph. So this is also interesting. We like to know the Ramsey numbers between the union of graph GI with H, yeah, in relation with Ramsey numbers for each component with H versus H here. So we can show that, okay, if this condition satisfied, then the Ramsey numbers of union is equal the Ramsey numbers for each component, yeah, versus H, and then we plus this the sum of the orders of G here. So here the interesting one, the sum here, yeah, the sum here is just depend on the number of vertices, not depend on the structures of the graph G, GI, yeah. So, okay, so yeah, yeah, and these results, then in 2009 improved by Bilak, and they consider if If S is equal 1, then the Ramsey numbers of the union of graph is this number. And then afterwards, we improve again this result by showing that not only if S equal 1, we can show for S greater than or equal 1 here. So we put here additional number here, S minus 1. So okay, the Ramsey numbers for G comma H, G is the union graph, then equal to this number for any S yet. So this is the last improvement for the union of graph, and hopefully, okay, yeah. And this is also another improvement as well. We improve the condition, yeah, the condition. If the condition is like this, then okay, we can have, okay, this is the bound. But now if we put further condition, yeah, then we have, okay, the exact value of these Ramsey numbers for the union graph G comma H. Yeah.
Okay. Sorry.
Yes.
The time is up.
Okay. I just want to mention this is the open problems for the union graph. So we still remain have this one to work on, and hopefully in the future we can solve one of them. So thank you very much for your attention. Thank you.
Good morning, ladies and gentlemen. This morning we have actually in maybe more interesting topic, and our topic this morning is virtual reality. Maybe some of us still a bit not know about what is virtual reality, and Professor Frederick will tell us to us about what is virtual reality and how to create model in virtual reality. Before that, I will tell you about who is Professor Frederick. Professor Frederick Merin, actually professor at Metis, Paris Tech, and the director of the Image Institute, a research team of the LE2IE laboratory. He received his PhD in 1996 at the National Polytechnic Institute of Grenoble. His research interests are focused on virtual immersion linked with engineering, cultural heritage, and health application. He is the author of many scientific papers in virtual reality and related discipline. He also involved in different projects with industrial partner and initiated international collaborative project in the area of virtual reality with universities in the USA, Australia, and Colombia. So hopefully we can have much view about the virtual reality. So please, Prof. Frederick, to present your paper.
Excuse me, I have to push a button. Okay, thank you. I want to thank the organization committee for the invitation. It was very pleasant to yesterday. It was a very pleasant day as well, and as well as the gala dinner, and it's a nice place. So my talk is mainly about virtual reality. So it's very technological-oriented topic. First of all, I want to present you my university. It's called Arts et Métiers ParisTech. It's quite the same as a University of Technology, part of ParisTech, which is a cluster-based organization on science and technology. And Arts et Métiers ParisTech is an old engineering school in France, founded in 1780. So Arts et Métiers means science and technology, in fact, 200 years ago. And we have 6,700 students and 10 sites in France with a headquarters in Paris. And the site where I work is in a small city, Chalon-sur-Saône, with a nice building focused on virtual reality. So Chalon-sur-Saône is a 50,000 people city, so it's one of the smallest university cities in France. And in fact, my lab is a 30 people lab. So why Chalon-sur-Saône? Because Chalon-sur-Saône is one main city of image, because Nicéphore Niepce made the first image on a printed paper in 1826. So you can see the first copy of the first image on the screen. And in Chalon, we wanted to develop a mix between engineering and image. And the result is virtual reality, which is a domain mixing the CAD data, the design process for engineering, and image. So my lab is focused on how we can immerse people in a virtual mock-up with two main topics. The first one is how to manage the virtual mock-up coming from CAD data, and the second one is how to manage the interfaces, virtual reality interfaces, in order to propose a multi-sensory experience to the user. And of course, all these things is very technological oriented, so we have a technological platform to do all these things. And because we are also an engineering school, we have lots of relationship with industry, and especially with Renault, and we share a lab with Renault. It's a joint laboratory called LIVE, for Virtual Immersion Lab. And we have several PhD theses and several collaborative projects with Renault, as well as joint development between our team. We also have several virtual reality facilities. In the same place, it's quite rare to find such facilities in France, especially. So virtual reality has for goal to propose an interaction between the user and the virtual mock-up. So this interaction is possible by action from user to the virtual mock-up and the perception of the result of this interaction from the virtual world. In fact, in the real world, we can perceive the object, the real object, through our senses, but how can we do that in the virtual world? So, in fact, we need technologies to act on senses. And basically the perception, the principle is to make the relation between a user in the real world, of course, and a virtual mock-up. We have to combine a specific interface between the two, So first of all, we have to capture the motion of the user to animate an avatar in the virtual world, and this avatar interacts with the virtual mockup. And the result of these interactions feed as a feedback to the user through his different senses, as vision, sound, and motion rendering, balance, and so on. All these technologies are called virtual reality. So in fact, we try to manage several technologies as real-time computer graphics and multi-sensory interfaces. And of course, our issues are mainly focused on how to provide the best virtual immersion to people. So we try to measure the immersion on the people, what we call the perception issue. Of course, these technologies can be used in many application domains. For example, in arts and multimedia application, lots of artists use this technology for artistic performance as well as user experience. For health applications, we can find some specific application on treatment for therapy, as well as tools for surgeons to train surgeons or to help surgeons during the operation. And for example, another good project was the one developed by Patterson called Snow World to help burn patients to accept the pain. Other applications are in the domain of training. For example, you can have some driving simulators for different engines, maintenance, as well as specific serious game to train people for specific tasks. In industry application, it is well used for design process to help people, to help engineers to have a better design of their product, and to help them to facilitate the maintenance and so on, and all the different product operation, process operation. And it is used as well in cultural heritage to preserve the heritage. One big issue, actually, especially, I don't know in other countries, but in France we have some big issue on the pollution in some portal, Roman portal, who destruct all the different portals. So what we try to do is to preserve it in acquiring the 3D digital equivalent representation, and to represent it for the people. So one important issue for us is to guarantee a good perception of the user in the virtual environment, in the virtual world. And the goal, of course, is not to have the same representation in the virtual world as in the real, but to transpose the situation in a virtual world in order to have quite the same perception. So the goal is not to copy the real, but to have another experience and to touch the experience. So I can show you small video here showing work done in my lab by students of mine. It's mainly the use of serious game application to train people to extinguisher, for example, to manipulation of extinguisher. So it's quite. So the goal was to train people to have the same gesture as they could have in the world, in the real world. So some issues we have is in terms of behavior of the people in the virtual world. So in terms of perception, with some problems linked to this, what we call the cyber sickness. We also have some question about the representation of the world and what is the representation of the virtual space when people experiment the virtual immersion, as well as the scale 1 perception, the distance perception. And another issue is how to navigate, how to interact as well in the virtual environment. So we always, we often use the Pinocchio metaphor because you always have your own avatar in the virtual world. And one main subject is, one main issue is how is your perception of the manipulation of your avatar in terms of transfer. So the question is how to go from first person to third person. So as you can understand, the concept of all this topic is a mix between two scientific community, one on technologies, and we talked about immersion, so navigation, interaction, multisensory things. And the second one, the second scientific domain is linked to human factors, and we called on the measurement of sense of presence of the people in the virtual world, how to experience the virtual reality, and how to integrate a virtual avatar as a part of ourselves. So main characteristics of virtual reality is that compared to video games, for example, is that in virtual reality, all your body is engaged in the experience. It is an interactive experience as well, and if possible, not only vision but other senses are excited. So to do that, it's a big engineering problem. We have several scientific and technological issues on how, firstly, how to build the virtual mockup coming from CAD data. So mainly it's an issue on simplification and a dedicated mockup for the virtual reality experience. A second issue is linked to VR technologies and interaction, navigation, and so on, how to facilitate the immersion of the people inside the virtual scene. And the third one, of course, the main goal is, the main issue is the perception of people inside the virtual world. So how can we measure the sense of presence of the people in order to adjust, to have a good adjustment of technologies. So in terms of managing the virtual, the digital mockup to virtual mockup, one issue is to adapt the data to real time. It means, for example, if you want to visualize CAD data, you have to render it in real time. It means that if the people move in the scene, you have to refresh the image. And typically, the frame rate is about 100 Hertz. So you have to refresh 100 times a second, the image. For haptic, for force feedback rendering, for example, it's 1000 Hertz, so it's much more fast. And so you have to adapt the digital mockup to this constraint. And usually it's a simplification process we have to do, but dedicated to this specific senses. So we have, in fact, in reality, we have several mock-up dedicated for each sense. So as you can see, all this engineering process is guided by human perception. In terms of technologies, we can use several technology coming from video games or interfaces as well to capture the motion body, to see, to touch, to perceive. We have several navigation interfaces to propose a possible motion of the people inside the virtual scene using several interfaces. For example, we use often joystick coming from video games, and the adjustment of this technology is can be quite complex in order to be well adjusted to the people, because you have to propose the best matching between the interface, the application, and the user. So in fact, for this simple device, which is a joystick, all of us know this device, we control the device in acting on the angle of the joystick, which act on the speed. So it's called the control technique, and you have to adjust how the speed will be depending on the angle. So it's called the control mapping. So all these parameters have to be chosen depending on the user profile, the application, and of course the technology. So now I wanted to present you some projects, and I want to present you one main project done in my lab 8 years ago, which was a very huge project linked to a Cluny-free church, so cultural heritage application, in the framework of the birthday of Cluny Monastery, so 1,100 years old. And so this monastery was founded in 910, and it was destroyed after the French Revolution in 1783. It was one of the biggest church in Europe, and we wanted to rebuild it in digital, of course, in order to present it as a tool for archaeologists as well as demonstrators for tourism. So we did it as with engineering process, but with the help of archaeologists as well. And so we decompose the problem in three ways. First, the data management. Secondly, the 3D modeling, and third, the virtual immersion. So we first collect some data coming from several drawings, as well as data coming from excavations. And we manage data as we can manage an airplane, for example, in divides the church in several parts, and each part is named depending on its size and the location in the church. We also did some scanning, 3D scanning acquisition because 90% of the church was destroyed, but it's still 10%. So we scan the existing part, and we do it with a scanner, with a 3D scanner. So we use several 3D scanners, one for large distance, and another one for small pieces with a better accuracy. As you can see, you have to manipulate a robot, arm robot, in order to scan all the piece, and after that you can reconstruct in cloud points the data, the object. After that, we model the data in reconstructing it with a mesh. So we use several softwares to do that, and after that we made like a reverse engineering thing in order to construct a virtual mockup adapted to the point clouds we have from the 3D scanner. So it's quite like inverse engineering modeling, and we use CAD data software to do that. After that, we can include the 3D scanned fragments on the reconstructed model of the church. Another way to do that, and we did that in another project, is to use photo modeling technologies. So the basic principle is to use images in the scene, panoramic shooting and so on, and you can reconstruct the 3D model in order to do that. And we did that in a small chapel in order to do virtual rehabilitation. So you have in this movie you have the two representations. The first one is the actual state, and the second one is a rehabilitated one. After all this modeling, all this 3D modeling, we can we can propose a virtual immersion inside the virtual church. And what we did is to combine the real lighting to produce coherent images. So I can show you a small video as well. So there is no textures in this model, in this 3D model, but the work was on the lighting rendering. Because one main characteristics of this church in its design was the light issue, the lighting issue. As you can see, the light is focused on the core, the main core of church. I have sound, but I don't know. It's complex too. So we also propose a virtual immersion experience in stereoscopic rendering, with stereoscopic rendering, for archaeologists, as a tool for archaeologists, and they use it to verify some hypotheses on the reconstructed church. And we also work, after that, we worked on an augmented reality device in order to propose a virtual immersion through an augmented reality device in the site of the church. So in this image, you can see some image coming from existing parts, as well as hypothetic parts. And the goal was to combine these two images with coherence in terms of lighting rendering. And for that, we capture the real light in order to create the virtual image. So this is a device we developed, and this device was installed in several places around the church for the tourism, and it has been designed by the lab and developed by a startup company called On Situ, which is the first startup company we created in the lab. So this is a small video showing this device. So it's like a window through the past. You can see the past as you could be, because of the lighting rendering as well as some texture rendering. So the device is fixed in the site because in augmented reality we still have some issue on precise localization, and because we wanted to have the good point of view, we fixed the device. So future work would be probably to enable the use of PC tablet and so on in moving around the church. So we have almost 4 devices in the church site, as you can see in this image. After that, we also work on polychromy rendering, and this is a small video showing the results based on this information. So information were collected from archaeologists, and they guide engineers to model, to put textures, a good texture, on the 3D model in order to render this thing. And we also try to put the 3D scanning model inside the virtual scene. And it helps as well archaeologists to verify their hypotheses. So there are some fragments collected from different sites. Of course, this painting is a hypothetical one. Okay, so I want now to go for the presentation of an industrial project called Arriva for augmented reality for vehicle architecture and virtual assessment. And the goal here was to use virtual immersion technology in order to propose some development for architects, for vehicle architects, as well as designer. So first work was to develop some tools, some method and tools to manage the CAD data. And because of the visualization constraints, we have to simplify the data, the CAD data, in an automatic way. So we work, for example, with offline simplification process, where we can simplify largely some parts, some CAD parts, with a reduction factor of 10. This is some results coming from our methods. So we can simplify largely the CAD data without any visual losses. And we can do that as well online. If you know the point of view of the user, you can simplify the data in the for the parts, for the 3D parts, which is not directly viewed by the user, or if the part is viewed at the peripheral vision of the user. So it's what we did. So as you can see, we try to manage the technology in function of the user point of view, of the human factors. We also, 5 minutes, okay. We also manage some shaders, which is textures, in order to give good feedback in terms of image rendering without any complex 3D model. So this is some images to see that. And we did some tone mapping adaptation as well. So it's mainly a perception issue as well. But so we try to simplify the mock-up depending on the perception issue. And yes, I just wanted to show you these things. The goal of this work was to propose a device inside a virtual environment in order to evaluate a virtual mock-up of a car. So because it's important for people to be sit in a real seat and to touch a real wheel, these two parts are real and all other parts are virtual. So we can, so we had some research issue on the scale 1 perception in the virtual vehicle, as well as interaction issue. And we try to use visual metaphor, because all is virtual, so you can go through the virtual mock-up, of course. But if you want to touch the mock-up, you must have a feedback to the user. And we use sound rendering or visual metaphor rendering. A strong issue we have in virtual in driving simulation, for example, especially in driving simulation, is that if you surround the user with large visualization system, he has a sense of movement, of motion. And to avoid some sickness issue, some motion sickness issue, you have to excite as well the vestibular system, so the sense of balance. And for that, you have to put all the simulator on a dynamic platform, and it's why we have So it's quite more complex than in a video game, because in video game, you know that you are the third person. You control an avatar, a distant avatar, but in virtual reality, you are your avatar, in fact. So you are in empathy with your avatar. That's the difference. And in another project, we develop, so it's a project called, called ADAS. It's quite the same, but we wanted to evaluate what we call ADAS, Advanced Driver Assistance Systems, inside in driving situation. So we need to have a virtual cockpit, virtual car cockpit. And for that, we have to construct a virtual cockpit around the user and to propose him to drive in the virtual world without any motion sickness. We built this simple system in actuator. As you can see, it moves a little bit. I have quite finished.
Yep.
And another thing, I just wanted to finish with research work we recently developed with Brawijaya University. It was the work of year one, a postmaster student, enabled to visualize in a virtual environment system data coming from geological data, coming from earthquake data. So thank you for your attention.
Okay, thank you very much, Professor Frederick.
Currently, he is head of MGC Innovation Lab in Okayama University Incubator. He is author of about 400 original papers in international journals, and also 40 books of chapter, mainly in analytical chemistry. He also received several international awards. For example, Warsaw University Award in 2000, JSAC Award in 2001, and Sanyo News Award in 2009. So, Professor Soji Mutipsi, time is yours.
Thank you very much for a kind introduction, Dr. Sabar. Good morning. Sorry. Okay. Good morning, ladies and gentlemen. First of all, I would like to address my sincere thanks to the organizing committee and Chairperson, Dr. Ruckman. And this is my first visit to Indonesia, but I am very happy to be here and to see numbers of old friends and new friends here. Thank you very much. Today, I would like to show the computer-controlled solution handling system for chemical analysis. Have you seen this film? Very famous movie. Yes, Titanic. About 100 years ago, the Titanic in the midnight, Titanic crashed with the large iceberg. Titanic is a very large, gorgeous cargo passenger ship. However, This ship broke down into 2 pieces and went down to the bottom of the sea. More than 1,500 people were died. Only 700 people were alive. Why did Titanic disaster happen? Because nobody knew the brittleness of iron steel at that time. Brittleness means the easiness of the materials be broken. And the brittleness of iron steel is affected by a trace amount of boron and is more severe at the lower temperature. Fortunately, now we know that boron content must be controlled below 1 to 2 ppm in iron and steel. From these results, trace analysis in advanced material is basically very important in all time. Recently, the one paper was published titled "The Destroy." Original paper is Japanese, so I translated. Title is Destroy based on brittleness. Example is the Titanic disaster. Cause of the brittleness is the high, so much impurities of the iron steel, and unfortunately, the temperature of sea is too low, -2 degrees centigrade. So in conclusion, this disaster will not happen if the present materials, iron and steel, were used. This is the conclusion of this paper. For boron determination, we developed using chromatographic acid by detecting fluorophotometrically detecting. The other trace analysis, for example, phosphorus and silicon, these two methods were developed by Dr. Sabardin in my lab. Detection limit is boron, for boron 3 ppt, and phosphorus and silicon is 60 ppt. Such detection limit is enough for the determination of trace amount of boron in iron and steel. Now in Japan, the trace amount of boron is analyzed by using this chromatographic method. Okay. Techniques for chemical analysis is now mainly 2 methods are available. One is the non-destructive method. The other is the destructive method. But the non-destructive method is somewhat error, the limit of the detection limit is not so high and not so low, sorry, not so low. And for trace analysis, this non-destructive method is not so good, and reproducibility is also not so good. So in many cases, destructive method, this means the samples were destructive, and aqueous solution were prepared. After that, some solution handling, the detection will be performed. Such solution handling is very important for chemical analysis, for reliable and high quality analysis. However, such trace handling, solution handling is very tedious, time-consuming, and sometimes you need special techniques. So now the automated solution handling techniques are demanded. I think such automated solution handling can be performed by using the flow injection-based method and sequential injection-based method. This flow-based method is very promising for automation of solution handling. First, I will show you the conventional flow injection analysis system. This shows the double stream system. Carrier and reagent solution flow into the small bore PTFE tube and merged here, and this solution is mixed in the reaction coil and detected. Sample is injected in the carrier solution and merged here and reacted and detected. This system is a very simple one. However, you can see this is the nitrite determination data. In this case, river water was analyzed. Nitrite concentration is 10 to the 6 molar. Reproducibility test, the relative standard deviation is 0.6%. Better than manual method and very high-speed analysis. And detection limit is enough for the environmental sample analysis. Just install the reduction column here in the carrier solution. Nitrate can be detected. RSV 0.3%. In manual method, this nitrate determination is very time-consuming and tedious procedure. The other example is a two-syringe type flow injection analysis. In this case, chromium-6 is measured. Calibration graph is very nice. Okay, next I'll show you the sequential injection system. SIA can be assembled by using the syringe pump or syringe plunger pump is also okay, and selection valve. And by using the pump, for example, reagent 1 is aspirated in the holding coil. Next sample is aspirated in the holding coil. Okay, and if necessary, reagent 2 is aspirated in the holding coil. Finally, this solution zone is dispensed toward the detector. This sample zone is mixed here. Okay, very simple. This is a computer-controlled system. This is a system assembled by our lab, SIA system. This system is used for the nitride determination. In this case, the nitride concentration is very low, 10 to the minus 7 molar, so the RSD is 3.5%, not so good, but enough for the environmental analysis. LOD is 10 to the minus 8 molar, very sensitive method. Next is the chromium 6 determination. Trace amount of chromium is carcinogenic. In this case, 10 to the minus 7 molar can be measured. Now, WHO guideline for chromium 6 is 50 micron per liter, around 10 to the minus 6 molar. So this method is enough sensitivity for chromium. Bead injection or rubber valve technique can be possible by using this SIA system. Automation of solution handling can be performed simply by assembling computer controllable CC pumping and valve module with the PC software. PC software is very important. Now, CC modules available commercially, the long type syringe pump and short type syringe pump, selection and switching valve, solenoid pump and valve, plunger type pump, 12-port selection valve, and solenoid, selection and switching valve, and peristaltic pump. This slide shows the made in Japan's plunger type pump, air pump, 12-port selection, switching, and the other valve module. These module can be used for the high pressure system assembly. I assembled one system for the column plate treatment. We say autoplate system using 12-port selection valve and switching valve. And here the plunger type pump. First, in our lab, we use the software controlling system based on lab view. Dr. Sabar used this system first. Later, Dr. Lukman improved the software based on Visual Basic. This is better than lab view system. Fundamentally, this software can control 15 pump, 15 valve, 15 solenoid pump and valve. These numbers is enough for the very complex system assembly. In this software, enough commands are included. For example, aspirate as a total volume and speed, dispense, total volume and speed, and and so. First, I would like to show you the simple fear system using solenoid pump. Here the solenoid pump. A very simple fear system with LED detector. And the other is the fully automated sear system using solenoid pump and valve. In this case, nitrite and nitrate were determined simultaneously. Each calibration graph is very nice, and this is a similar solenoid pump and valve system. I'll show you the next example, a new concept of simple fluidic flow chemical analysis system. Simultaneous injection effective mixing analysis system. We say SEMA. This system is somewhat hybrid of FEAR and SEER. This is a real system. I'll show you the principle of SEMA. First, valve is changed, and reagent sample and reagent is aspirated in the holding coil, and syringe filled with carrier, and this solution flowed toward the detector. Here the reaction coil. Very simple system, but the very useful system. In this case, the ion 2 and total ion is simultaneously detected, and this is the nitrite and nitrate determination system. Here the nitrite determination, and here the nitrate determination. For river water sample, this system can be used. Next is the solution handling for solid phase extraction. Usually the manual batch-wise procedure, solid phase extraction can be performed by using such a mini column, 1 cent, total volume is 1 to 10 milliliter, and the solid phase is packed here. But this manual method is very time consuming, very tedious, and not so reproducible. So we automated this solid phase extraction. Syringe pump, selection valve, and column is on the switching valve. Here the advantage of this automated column plate treatment system. We say autoplate system. simple and convenience operation, fast and high sample throughput, less reagent consumption, full automation, comparable LOD to those of ICP-MS when 10 to 20 milliliter of sample and ICP-AS used. This system is almost the same. This slide was prepared by Dr. Sabar or Dr. Rukman? Yeah, Dr. Rukman. Very nice animation. First, column is conditioned with conditioning water. And second, correction analyte is correct on the column. And third, washing with, in this case, carrier solution. And finally, the elution. In this case, the eluent was sandwiched with air for not dispersion. Okay. By using this system, we can easily automate the SPE. This is some result of the concentrated sample detection. This peak is a 5 ppb, and this is a 20 ppb. Concentration efficiency is more than 20 or sometimes 100. This is the LOD. You can see the several PPT or PPB level. And this is the analytical result of Asahi River and Zas River near Okayama University. On the 8-port switching valve, Dr. Sabarodi installed 2 columns for speciation of chromium-3 and chromium-6 determination. Dr. Sabar synthesized the CCTS-HPA new solid phase for correction of chromium. Very interesting solid phase. You can see that around pH 3, the chromium 6 is corrected. However, the chromium 3 cannot be corrected. Speciation. Final example is the multi-autoplate system. In this case, 3 autoplate is working simultaneously. This is the software 1, 2, 3. Skip. This software and the system can be used for the flow titration. 2 syringe pump under the same total volume, total flow volume. The 2 syringe pump, the flow rate is gradually increase and decrease. This is the example of the calibration graph. Very nice linearity, and they go through the origin. And the other strong and weak acid. Sorry. You can see the HCl, strong acid and weak acid. Acetic acid is the same calibration graph. This means the strong and weak acid reacted completely in this system. And dibasic acid, sulfuric acid, the slope is twice compared to the monobasic acid. Okay, the SIA or autoplate can be used for the other detection system. Liquid electroplasma is very interesting, but this time I'll skip. And one more metal analysis, the small potential stat can be available now. So some electrochemistry is connected to the SIA or autoplate, like this. This is the arsenic determination, and this is the mercury determination. I'm very interested in such a universal system, but yesterday some of them I presented at the poster session, so they skip today. More time?
10 minutes left.
10 minutes. Okay. And next generation of computer controllable pumping module and valve module, high pressure plunger type pump is more useful for high pressure sequential injection chromatography and solid phase extraction. And high pressure, long life ceramic valve is also necessary. But now, in Japan, such a high pressure type pump and valve is available. And very interesting is the nano flow pump and valve module. This is the high pressure type. And this is nano flow pump module and nano flow valve module. Very small type and controlled by our software. Nano valve. Nano pump is the X nanoliter per second. Conclusion, the advantage of the automated solution handling is very several advantages are considered. However, of the automation of tedious, complex, and repeating procedures, and especially technical procedures, is more important. And for chemical analysis, improvement of quality and reliability, such as sensitivity, reproducibility, simplicity, and robustness, is much more important, I think. I would like to conclude my talk with acknowledgement to the 4 persons came from Indonesia to my lab. I would like to address my sincere thanks to Dr. Joko, and Dr. Sabaruddin, Dr. Lukman, and Dr. Rossi. Thank you very much for their untiring endeavors on study research in analytical chemistry lab and contribution to the frontier of analytical chemistry. Thank you again. Several photos. Joko and his friend. And 2004, we went to the annual symposium on analytical chemistry in Okinawa. Except me, other international students. Sabar is here, and the pin, Kanchana Rising. And after the symposium, we enjoyed the Okinawa traditional fishing. And this is the flow injection analysis conference, symposium in Japan. Sabaruddin and Rossi. And this is the three persons, Lukman, Rossi, and Sabar in one photo. Only one photo. And this is the best poster award in Pacific Chem 205, Sabaruddin and Lukman awarded. Very nice award. And 206, Dr. Lukman and his family in Okayama. Sorry, just before leaving Okayama for Malang. Thank you very much. Lukman, send me. Thank you very much.
The representative from PT Jasa Raya, Mr. Duyanto Swandaru, or just call Pak Yanto, will present their product. And I think because we have time constraint that the committee has mentioned, maybe we will have only 10 minutes. And then if you have something, then you can come to the booth for more talk. I give the time to Pak Yanto. Ya, silakan.
Okay. Thank you, Pak Johan. Good morning, ladies and gentlemen. My name is Duyanto Swandaru. I'm from PT Jasa Raya Tama Jaya Buana. PT Jasa Raya Tama Jaya Buana is exclusive distributor for many databases for market in Indonesia. And this session I will introduce the Royal Society of Chemistry, and their databases is called RC Gold. Sorry. Yes, IRC, the world's leading chemistry community that's based in UK, Europe, and we advancing excellent in chemical sciences. And why we do it is to shape the future of the chemical sciences for the benefit of science and humanity. And what drive us is bringing chemical scientists together, promoting and sharing knowledge, ideas. So we are not for-profit organization with over 51,000 members across the globe and heritage that span for 170 years. And we have an ambitious international vision for the future. And the Royal Society of Chemistry has just the recommendation about the people, the publication, and the connection. And what is RSC Publishing? This one of RSC department in Royal Society of Chemistry, and they publish journal like Chemical Science and Journal of Material Chemistry, and there is a 41 journal until 2015. And we have published the literature like analytical abstract, synthetic reaction updates, chemical hazard in industry, laboratory hazard bulletin, and natural product updates. And we publish the books and e-books like education is in chemistry. And this is our product or database is RRC Gold. In RRC Gold, we one package. We have a journal and e-books and literature, and then RRC Publishing also published the Marine Lit, this journal for marine natural product literature, and Merck Index Online, and SemSpider is a free chemical database. And what is our scope? Chemical science, energy environment sciences, food science, medicinal chemistry and biomolecular sciences, and nanopolymer and material science, and over 1 million journal, article, database record, and book chapter, and over 32 million chemical structure in SemSpider for 470 data sources, and 41 international peer-reviewed journal. Over 1,200 books and e-books, and 5 literary updating services, 2 magazines, and 2 databases. And we look the article growth from 2008 until now, 2015. In 2008, we published Energy Environment Science, and 2009 there is 4 journal. Analytic method, metabolomic, integrative biology, and nanoscale. And 2010, there is 4 journal. And 2011, RC Advances. And then 2012, 13, there is 3 publication in 2014. And 2015 there is new, the Referential Science for Water Research and Technology. And this is our impact. You can trust, of course, the Royal Society of Chemistry Journal to deliver high quality content, because our exceptional standards are reinforced by the 2013 Journal Station Report, and 6 of 20 journals in multidisciplinary chemistry category are published by us. 33% of our journal have an impact factor above 5, and 83% above 3. And the 3/4 of our journal are in top 20% of their ICA categories. And for average impact factor relation over 5.7. And our international influence is that in 2015 over 1,013 authors from 85 countries published with us. And our editorial board members are truly international. Based in UK, Cambridge, there is also office in Sao Paulo, Brazil, Beijing, and Shanghai, Berlin, Bangalore, Tokyo, Japan, Philadelphia, Washington, D.C., and USA. And editorial board members, there is the list of editorial members by country. You see the UK, Canada, Korea, Spain, Italy, and many more. And our global visibility as our sustained and fresh international growth has been recognized through the UK Most Prestigious Business Award in 2013, the Queen Award for Enterprise for the RSC. There is a database. In our database is RRC Gold. It's fantastic research from the Royal Society of Chemistry. There is all online journal, database, and magazine content in one package. so you can elaborate your RSC Gold is also ever increasing value in content, with all new journal being automatically added to your package as they publish at no extra cost. As RSC Gold subscribers have access to content is growing, increased by 60% in 2014, and with optional standard reinforced by high citation, a top 20 journal. You see that's now more than any other publisher. There is 16 journals have been added to RSC Gold on publications in 2008. RSC Gold includes all Royal Society of Chemistry journal, literature, updating services, magazine, online content, and our journal archive list in 1841 to 2007, bonus book series, and this may be interesting for you. That's voucher codes to publish in Gold open access free of charge. And RSC Gold customer can now apply to join the RSC partner program at no additional charge. So this is our new program, Gold for Gold, that RSC Gold subscribers are entitled to select number of voucher codes which can be used to publish accepted paper in the Royal Society of Chemistry paper via our RSC Gold open access option. Each voucher code can be used to publish one paper. There is maybe for RSC subscriber have 10 voucher code can be used to publish the manuscript or paper in RSC Gold open access. So what do library think about RSC Gold? This is the last slide, but then following your faculty team and University of Leeds, they said the RSC Gold not only supporting our chemistry-focused research, but also enriching our interdisciplinary activity field of food science, nanotechnology, environmental science, and more. And Jeremy Gaetiano, Chemical Information Specialist Associate Professor of Library Science, Purdue University, he said that the RSC Gold collection will assist in achieving the discovery of tomorrow. So if you interest to join with us, please go to our booth, and you can reach us to email in info@jasatama.net. Okay, thank you for your attention. Good morning.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. On behalf of the Rector of Universitas Brawijaya, we would like to give our gratitude for the keynote speakers. I still see here Professor Frederick, Professor Hideki Tanaka, Professor Aulaniam somewhere, I guess, maybe. Professor Soji Motomisu, Professor Fahrul Zaman Yusuf. Yeah. Well, I try to remember the name of you, but sorry for the limited of my memory. And then also, I guess, some keynote speakers, many thanks. I see here Dr. Duang Che from Mahidol University, and then Karanchai, well, maybe wrong. Yeah, I mean that. Also, Dr. Edi Priyo Utomo, Dr. Sasmito Jati, and, well, sorry, maybe another people that I cannot mention here. Dr. Edi coming, thank you. And then also our appreciation for all of you, the oral presentation. and then also for the contributor of the poster presentation, and for the some participants, I still see here a guys from Gorontalo. Thank you very much. Still side there behind. And last but not least, my appreciation to all of the steering and organizing committee for running this conference very well. Thank you very much. And finally, by praying and saying Alhamdulillahirabbil alamin, this conference is officially closed. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.